Euclid's Elements, Book 3, Proposition 23. On the same straight line, there cannot be constructed two similar and unequal segments of circles on the same side. So first we should probably define what Euclid means by similar segments. And in definition 11 of Book 3, he defines similar segments as segments of circles that admit of the same angle. So if you have two segments of circles, which is just cut off, this is a piece of a circle that's been cut off, if they admit equal angles, if this angle is equal to this angle, then the segments are called similar. So what this prop is saying is that if you have the same straight line, say line AB, and you have two similar segments, so here's segment ACB, and you have another similar segment, call it ADB. If they're similar and unequal, you can't construct them on the same side of the same straight line. If they're unequal, they won't coincide, so one or the other will be above. It doesn't matter which one is above and which one's below. The proof works the same either way. So this is a proof by contradiction. So we're going to say if it were possible to construct two similar segments of circles that are unequal on the same side, let us do so and let them look like this. So what we can do is we'll draw a line from A through C to D, and then we'll connect DB and CB. And what we should note here is because they're similar, they're going to have the same angle. So this angle here is going to be the same as this angle here. So we'll just call this the angle. The angle at D will be equal to the angle at C by definition. So this is because of this. But we also know, because of Book 1, Prop 16, that we have a triangle, and this is an exterior angle to this triangle. And any exterior angle is greater than the opposite interior angle. Therefore, the angle at C is greater than the angle at D. But that's a problem. We just said that C is equal to D, and now C is greater than D. Well, that's our contradiction. Therefore, the assumption that gave rise to that contradiction must be rejected. Namely, if you have similar but unequal segments, they cannot be constructed on the same side of the same straight line. Since that's what we're given to prove, we conclude QED.